Oh, hello everyone. How are we all doing? I'm newtmechanist, and today we're continuing our game dev project. I did a little research, and there's some decisions we need to make. Less of a what and more of a how, but I think we'll be able to move along pretty steadily. Okay, never mind. Hey there, Key. Hey there. Checking in with the kitties real quick. Ember and Sky crammed up in the tree there. Mason and Sammy on the bed. Sherbet's watching the TV. Molly is just off camera of the table there. She's sitting next to the dehumidifier, or the humidifier that I do need to fill up at some point today. Oh, dear, dear, dear. Okay. So we were getting started with our shader logic. And I found a lot of references of what I did with shaders last time that will be able to clean this giant mess up. Like, we can not do this. We don't have to do this mess. Well, we don't have to do this so sloppily. There's still some stuff that I want to verify on it, but I think we can do... I think I've got the resources for cleaning that up. But getting it done correctly creates a bit of a question for us. And let's... So right now we have our game start, time passes, let's say step. Switch that around. It is the game start step, the game end step. This is the actual like Godot side game loop. So every so often we get a physics is happening tick, and we go through start, time passes, we apply the delta, or we emit the delta to anybody listening, and then we end the game step. So this is constant, and it's this is frequently happening, and it's happening at relatively arbitrary intervals. Now, Godot tries to keep it at a particular pace. You want physics to happen consistently, but if it gets bogged down, it will slow down. Inside of that, we have our world start, world time pass, and world end. Step in there. And we don't need to save you. So while this is the Godot cycle tick, world is the actual simulation side tick. That's where we're running kind of the behavioral scripting, that kind of thing for all the entities, processing what happens. Molly is a very whiny cat. She is snuggly. She will lay there with you. She likes to get, light pets, but she's really touchy if you try to move her much. Well, I'm sorry. Speaking of, no. Just don't move me. Giving her some nice head rubs here. She is such a staticky cat, though. just walking across to me and laying down, I can see her fur standing on end along her back. And just rubbing your hand along her once will make it worse and can build up enough of a charge to get a shock. Just the nature of her particular fluff that it's worse. I mean, Sky has enough fluff that it builds up really easy, but Molly, despite being a short hair, Molly doesn't have that, and she generates more than him, whereas all the other short hairs don't. Interesting variations in physiology, you know? She is. I finally got the electrostatic mat for my desk set up properly. It's got a proper ground now that is... I mean, it's a proper ground as opposed to just the... I was hoping it would ground, but it didn't. So occasionally I can reach over and touch the mat, or in particular touch the wire that runs off of the mat. And it can be a bit of a painful shock, but it at least prevents it from rebooting my keyboard, mouse, all that stuff. Okay, so we have this. In previously, we would have physics here. And what physics step was, and then actually, quit. I'm compulsively doing Control S. I do that constantly when I'm writing stuff, so I don't have a bunch of unsaved changes. So this is all happening in the Godot physics process. Hey there, Lunar. Did you add the TV that has newsreels about what you've done, similar to Evil Genius has the for a radio yet? No, but that's a fun idea as far as like a late pass kind of stuff. I was joking with somebody about how in Helldivers you get an end summary. When it started, all of the, no matter how you performed in the mission, even if you fully failed, there was always an indication of victory. To play into the propaganda vibes of the game. You are you are the frontline soldiers of a totalitarian state. So everything you do, every operation is a success, even if it wasn't, kind of stuff. For a while, they actually had failure messages that they swapped over to, and you had to get like mostly a victory to get a positive result, but they've since switched back to indicate mostly, no, this was great kind of stuff. Still, there are some failure states. I feel like they're missing the opportunity to lean in some of the places. But it would be kind of neat if leading into the missions and exiting the missions, you got the very... The very propaganda speak aspects of it. You're doing this for reasons that, sound noble, but actually we're just trying to steal oil kind of stuff. Yeah, this was a total botch job, but we're actually going to spin it to sound like it was actually a success for a completely different reason. Having that kind of thing, having like news broadcasts or stuff as like animations in between levels would be kind of cool. But that is very much a finishing touches kind of thing. Yeah, losing save states is a big pain key. We've had a couple of streams and games that have been derailed by losing save states. because we'll have things like we need to backtrack through a whole bunch of intricate stuff that we did over the last like few hours or stream kind of thing. Happily not on the coding side. That's part of the reason that I'm using the sort of source control that I am, is that if something goes wrong, I have save states to fall back to. And that's why I stop and will periodically put down save states, so that if I break something, I can at least fall back. And if something goes wrong with the local PC, I don't lose what's on the, like, that something corrupting a drive doesn't blow it out either. Okay, so all of this is in the Godot physics process call. We're going to put before this, but it could also be after this step. But it's between physics process calls. We have the Godot. We have the Godot physics calculations. I don't need to save right now. And what we were running into, the reason that we started going down the road of the shaders again, I looked at my audio blips and I had the concerning impression that, like, wait, is my microphone not coming through? But that was part of the problem, is that... Okay, one second. Just gonna... Otherwise, I'm just going to keep doing that. There we go. I put it in a save. I saved it. Is that the snapshot that this works from ideally accounts for everything that happens here, but the way that we need to move objects around, since we're not using the Godot body physics simulations, can result in this snapshot not accounting for stuff that happened here. It will eventually, but it might mean that something that collided in this step, a collision that happens here and is processed here, resulting in a world state where another collision won't happen, could still get collisions from a prior snapshot. Like, it won't be updated until we get back around. And since I can't tell whether a collision is from a stale state or a fresh state, we have a problem. So we are getting rid of our reliance on this. Do we have a quick font thing for strike through? All kinds of other stuff, but I wonder if we can show that. Oh well, never mind. So we want to get rid of this step. And so we're going to move in shader, but that would be right around here. We are going to say so here we would kick off the physics shader. Everything that should happen this turn, we're going to sort of remove that. We kick off the shader here. So everything that has happened, let's mark that we're removing it. Everything that has been processed in the world, all of the stuff that's going to move, is ready to move. And in fact, as of here, the moves happened. Then we're going to say, given all of that information, we're going to start the physics shader and see what kind of collisions result from that. We need to get that, and we can't just ask right here. Can't ask right away. We need to give it actual time to run. So we packed up a lot of data. Hey there, James. Welcome. Yeah, I found all of the old notes for doing like the compute shaders properly, and in fact some extra good stuff for setting them up correctly. Like right, this kind of thing here is, I think I forgot this previously, this is saying lay this structure out exactly as it is here, like in this order, in this exact order. Because this will happen subsequently. And as long as we keep our nice float alignment here, when this one drops in, it creates a bunch of empty space and it fills it in for us. If you don't do that, then you have to try to ensure that the memory lines up exactly how you want it to otherwise, and that's a problem. But anyway, found all this cool stuff. Again, back when we did the physics shader way back. But I also found a pattern for actually having an async wait kind of thing. Not really. It's a built-in callback for a compute shader in Godot, where we can say, hey, I got the data back from the shader. So it'll do that for us, and that's fantastic. But the difficulty is when I get that, it's at an arbitrary moment. That could happen at any time. So I still have this loop going on here where I get my physics step. I say, okay, game start, game time passed, world step start. And world step needs enough time has passed. And the physics is ready. So unless both of these have happened, I can't proceed here. Now, I can add some events that say, okay, the physics step happened. I would have to change it to where instead of this is the kickoff of the physics step, this is physics step occurred. Like the physics manager would say, I am emitting the physics step. Here is the message that goes with it. And that message could be, yeah, everything is good or everything is not good. Then I could set a variable in here. And I think that might be where we go. Ultimately, I do want to change this to kind of a state machine where at each pass we have an opportunity to say, oh, okay, proceed to this state kind of thing. So that I can have that. But within that logic, I'm still going to need to have a flag that says, we got an okay on the physics side. Let the world step see if the world state is ready to move forward. If the world state says enough time passed and we see that physics is ready, then we go. So we could have a world state object that listens for game time passed, and it will say world step is ready. Because enough time has passed, and we've also got our physics step was ready. So then we can proceed into our world start step kind of logic. But I want to be cautious of that. So what we're probably going to be doing, at least today, is we're going to set up this in a sort of state manager. So we're going to go from here. We're going to get rid of physics step here. And we are going to have... I'm going to move you out so that we can get all of this lined up. Actually, let's put these back where they were. Okay, so we're going to have a game state object of some kind. And it's going to do our game start, game end step. So it's going to do these, and it's probably going to do these pretty linearly. Then we have our world state. And it's got world start, world time pass, okay, we're going to have a notation here. We're just going to use a star. And game time passes is something that it is listening to. And then we have physics state. And this is listening to world time passes. I'm sorry, world end step. Oh, that's not right. Okay, so what world end step is doing is so during time passes, we kind of queue everything up. And then in the world end step, we actually do the movement. So we might need a... So we're listening for game time passes. In game time passes, we need to have so we need to be able to check if physics is ready. And we can So we can keep using the game time pass delta and accumulate it to determine if enough game time has passed. So this check is entirely within the world state's control. But we need the physics is ready. So to get this, we're probably going to have a... Okay, so we'll have a flag inside that says physics is ready, because we need something else to tell us that physics is ready. I don't like that we've necessarily got that, but we have some options here. Let's incorporate that. So physics step is physics state is entirely us getting that data and kicking it off. So we have I keep typing Phyx, you know? So the physics state can have other workings in it, but the current one is going to we need to know that the world state changed. If those spelling dictionary entries of no, this is definitely a critical error kind of stuff. I do not mean that it's that. So part of our entanglement is so we can just have this is the first run, like physics is ready by default, because we don't care. But we need to get that information. We need to have those events, and they need to have been calculated before we can proceed into the next step. So we can solve this one. This one is largely solvable. Actually, no, well, they're all solvable. Let's be clear there. This is, again, largely the exactly how. But the physics step needs to know that the world state step is over. So part of this, I think, is going to be terminology and kind of phrasing in the names. So this is game end step, but there's kind of a something step here. Or we could have an after step that is these are things that stuff react to. I'm sorry, within it. So we expect the world state to change as a result of end step right now. So I can't do anything with physics state using this event because stuff happens here. So I could have after this, currently, that there is a world done and a game done step. And then physics could listen to the world done. Done is meant to be it's over. You're not meant to change things within the world. Or at least world processing should not happen here. So we call this, and then we're saying it's finished. Okay. So state machine wise, we've hit the end of our sequence and it's over. So that we can like recoil back as far as like game state, game time passes, kicks off the world state calculation. World state calculation finished, kicks off the physics state calculation. It does not need to do that, but this is a moment of at least loose direct coupling, is by putting a requirement for physics to be ready here, there is the assertion that both of these definitely exist kind of stuff. As far as the game state is concerned, by doing this, game state cares not for world state. So in this pattern, physics state is effectively part of the simulation state. That's okay. Okay. We need game time passes and we need physics done. And this largely is just for consistency. I like done. The steps were done or the steps are done. They both kind of work. Yeah. Okay, so we're going to have 3 different doodads as a result of this. We have the game object, which we are instantiating already. We're going to create a game state object, and the game state object is going to be the thing that drives all of this. Game is just the thing that creates everything. It says, I need this, 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 and this, and I shall poke this to start the ball rolling. But largely, game state is going to be the thing that emits these game messages. So in our existing game loop, I did rip out some other vestigial code before starting the stream here. Well, a good bit before, so I could determine if I blew something up. So what we're going to do in physics process here is that world start, physics, world time pass, world end step, all of that is leaving here. This is only going to have game start, time passed, game end, and game steps done. It will be another object that is world state. Now, I have a world state object here. This is going to be a completely different thing. It is currently unused in our system here. Because like level doesn't do anything, current time doesn't do anything. This is entirely going to be a listen and react and trigger messages kind of thingy. So again, this used to be the thing that drove the level. Now the level drives the level. The level used to just be a data structure. That was months ago, though. So we're going to rip this out. And pretty much we're going to empty this little guy out. And we'll build that. We'll run that just to be sure. There's still some camera flicker going on as far as initially moving the player. Because the player is suddenly moved to about this position, or they are moved down here, but the camera is previously up where they were, like at the very start. All right, so we have a world state, and the world state is going to say... Actually, this is another good thing. Okay. World state is not an interface, but we're going to use one for it. Or it is going to be a thing. So world state emits world start step emits Now, world state may have its own things, but primarily what world state is the core emitter for all of this stuff. Currently, nothing will need that, but I'm just doing this to have the shape of it in place. So we go over here and we say implement interface. This is going to have... I feel like we should change some of this syntax. Okay, let's get in there. Messages. So we have game steps, emits end step. Okay, and then world step, same thing. And world physics step emitter, we are going to rename you. And similarly with the physics step message, we are going to rename you physics done message. So we're doing some renaming to make it easier to actually implement these, because if we don't do what we're doing here, when we implement the interface, we can either do it as a, well, I'll do this as an I emits world time pass dot invoke, or I can just name it more verbosely in the dot invoke. It's just as good. Okay. Time passed message is still sufficiently generic. That's okay. Physics done message. Because end step, start step, there's nothing special about them right now. So then we are going to need to add a new item. Which is going to be, so now we'll make our done steps, or our steps done stuff. Public. That means we need a I emits game steps done Dinby Steos. I learned typing by programming before I learned typing for data entry. So I can do actual like data entry typing, like, you know, proper hand position to try to type fast, but I don't do that frequently at all. I'm typing to enter like weird keywords in code, which isn't necessarily suited at all for type super fast, you know? So I know generally where the keys are, but I'm gonna look on the regular, and the regular hand positions aren't as efficient for a lot of code stuff. But with that said, it doesn't stop me from emitting typos like crazy. Public event. Object sender game step. I do it the same way in there. Yeah, message. And then we need a we're not going to add emitters for this because we're going to get the relevant objects going forward. We'll add emitters. No, we're gonna do this. So right now I'm using these emitter classes. These are in between. Exactly, James. It just type however you can. And I mean, it's also not aided by the fact that I have Molly kind of draped over my left leg. A decent portion of her torso is just kind of dangling to the left under my armrest. Yeah, I'm talking about you. So not only am I, typing a lot of symbols and whatnot, so the regular typing not necessarily great for that. I'm also often reaching around cats. Okay, so all these like emitters here, I'm probably just going to add these to like the game object in similar. Yeah. Folder. Physics done, emits physics done. So these are general messages. We're actually going to change that. That's a steps done message. So we don't need a physics done message. Just so. Okay. So you have world state here. This isn't a service. Level is part of game. All right, let's... Hey there, Drew. Okay. Okay. Let's run this, make sure it's still largely functional. Check it on the Godot side. Okay. do a commit. Yeah, I mean, that's a tough situation, and what you're talking about, like caring for family members, and that is a large part of it, is just everybody helping each other out. And even somebody who's really extroverted, if they're being like emotionally affected as well, it's going to be super draining. And Ling handliner. Whoosh. We're going to move a bunch of stuff around here. We're cleaning up some of the structure inside of this. Because a lot of that stuff that I moved around was based on, again, when there was a world state object that controlled a lot of like the spawning pattern and all of that. We have completely moved on from that model. So I've removed a lot of the logic that was for the unused model, kept the used stuff, and moved it to where it has more functional relevance in folder structure. Okay. So we're going to add state. Organization is important. Okay, so in our constructor for this, it's game time passed. Services.resolve. And emits game time passed dot game time passed plus game time passed. And we're going to have a okay. We only care if physics is done if the fixed tick rate is ready. Let's see here. So we have another one, which is a protected float. Accumulated delta plus equals E dot delta. The pubble. Wow. Double. There we go. If. And let's go up to game here. We're going to get go into, let's close everything else. And we'll go to our base world state. We're going to get you. Delta is greater than or equal to fixed tick rate, then physics done and accumulated delta. Physics done is equal to false, and accumulated delta is 0. Now, we can do minus equals on this, but again, we're going to say no matter what, we move forward at this interval. Exactly this long will be weighted between each actual physics step in the world. Oak, sender, and message. And then we look at messages again for world step. We need emits world steps done. Event handler, steps done, message. Object sender, Steps done message. Steps done message. And then in our world state, and in base world state, this will be contains a time passed message. This is kind of redundant, but we're going to keep doing it. This copy. And invoke steps done. This new done step. Steps done message. Okay. So now it's when we get a game time passed message, the world state is going to see if it should fire. World state only fires if physics has we have gotten a physics is done message and we've accumulated enough time. Once both of these are true, we're going to essentially zero out our state again, and it's going to come back around. So we're going to also look for I emits physics done. Emits physics done. On physics done. And that is true. That's it. Okay, so then we're going to look in our services here. This is an ugly commit. I let too much pile up before I did this. Okay. Add scoped. My world state. Say base world state. Way. Oh, there's a pattern for doing this. Just a moment. I thought I remembered how to do this. Resolving. That open, but I didn't. Why would I do that? Oh. Just looking up code again. I closed the window on myself. So we're looking up how to do shared instances for multiple interfaces. Later, get required service. Okay. Should be. Get required service for that. Flashbang. That's why I normally close the screen here. Okay, that's that. I think that's what I'm doing. It's not a service, is it? Should work. Okay. Let's. Putting it in the wrong spot here. Let's keep trying. Yep. Come on, bud. Come on. Okay, okay. So instead of this, we are going to try this. There we go. So first we're saying it's one of these. It's the world state is this thing. And I want to have all of its individual like sub interfaces say it's this. Now, elsewhere in code, I could have each of them have their own emitter. This is just saying the world state one is also the emitter for all of these. And by doing this, it's not that one though. We'll get back to you. Like that. So what this should do is we're saying, okay, there is a service called this. Anytime that I want to get this one, I'm going to say, well, I actually want this one. Which means all of these should point to whatever this one gets instantiated as. So there's one world state object, but it can also be referenced by these individual interfaces for things that want that message. Troublemaker Sky, yeah. He's a little sweetheart. Some shoulder rubs and his little paws are flexing. He definitely wants attention right now, and if I don't provide it, he's going to climb up right in my face. Okay, so now we have our world state object in place. And game state is very similar. Public interface. And it's going to implement emits game start. Almost certainly never key, but I do try to remember to post new pictures of the kitties now and again. Fell out of the habit for a while, but largely not by intent, or by just forgetfulness. Posted some new ones recently. A lot of Molly. Past emits HNote game end step emits game steps done. Now, interestingly, again, there's actually a lot of stuff in game that doesn't need it to be a node 2D. The way we're going, because eventually I could put camera as its own entity, but for the time being, what we're going to do is this game state. All of our emit messages here, we're going to take those up near the top. All have the same pattern. Is if it exists, we invoke it. This end message. And we copy each of these in here. Just so. So then down here, we don't need these guys anymore. Similarly, we're going to need to emit physics done to keep this flowing. So we are going to take this up here. We need to have a paused event. Actually, no. This is game state, so we can check for that. If game state is paused, then we can proceed. Okay. Base world state. Game state. No, that's the game object. This is an actual game state thing, though. But this is an implementation. That's fine. Public Boolean paused. This gets and sets for a paused. So in game, this case, pause just has a get set. There's nothing special going on, but what this means is that I have a getter setter method. This is a full property with a get set that can handle it however the implementation needs to. So this still allows us to check for paused in our world state. Game state. State is equal to services resolve game state. So we're looking for not game state dot paused. So we're verifying, is it paused? Is it not paused? Physics is done, and we have accumulated a sufficient amount of time. Let's verify that we're still functional. This is amongst the things, is what we're saying. Yes, that this is one of the things that does. It also means that we are building in a way to decouple we are further decoupling the Godot physics process from the world simulation state. As it stands right now, the way that we've built it, there is nothing about the world state that cares that it is the Godot physics process. I could have something else entirely driving that loop. Okay, so back in services. Okay, yeah, we're not emitting physics done. So, oof. Okay, so right now we're cascading this in this fashion here. Okay, so right now we have a reference to the game object, which is that node 2D. For now, that's how it exists. But the game object is a game state object, or implements that interface. And whenever we want the game state, we want this thing. Whenever we want the emitters for start step, time passed, game end step, we want to get the game state thing. Just so that we cover all of our bases. 1 second, cat passing. You up here. And it is not this. For now, this is still going to be I emit our physics done. All right, so camera isn't functioning and our movement state is moving very slow. Just a moment, left something open. Do. Yeah, there we go. Test something here. Minus equals fixed tick rate. There we go. That's smoother. All right, we're doing it this way so you can never accumulate more than one tick. Like, you get one bit of leftovers, essentially. Let's see if that still is clean. Yep, okay. So then over in game... So the camera needs to be getting updated. Camera here. Run it on the Godot side and verify what, if anything, is going wrong here. Remote, core, game. Camera is present, it's just not moving. Ah, okay. So we're looking for camera handler.update. That got ripped out. Game. There we go. Okay, let's get that. Okay, so now world state is handling stuff, and game state is handling stuff. Eventually, we can move the game state handling. Hey there, Laura. Out of the actual game object, as well as clean that up. State, collision, inventory. Yep. Physics process. Invoke. Game steps done. This, comma new. Steps done message. Okay, so we have game steps done, and then in base world state, we have world steps done. So now we are going to add our physics state. Yeah. Public interface. Emits physics done. Just like with game, there isn't that. The physics state is handled by the corresponding collision handler, which is you. Collision managers also implement physics state. Up here. And if physics done exists, we invoke it. The sender and message. So then in services, right here, we have service collection. Are we putting our, where do we have our collision guy? Okay, we have that, and then whenever we need a high physics state, we are going to do like this one. So we're saying, give me the collision manager. And then when we're looking for physics done, we want physics state. Okay, so we'll run this again. Okay, still functional, so let's get a stamp here. Okay. All right, so now we have all of our state handlers, and we have the ability to react when we get physics messages done. Cool. Now, we want to get our shader running, but it doesn't need to do anything. We just need to trigger it. For now. About you. Those will be useful. Still need entity added and relevant entity events. Not what we're looking for there. Still need entity added. Emits world steps done. Emits world steps done. Okay, so we are going to need to go through our flow now. Rendering device, and then we trigger our async. We're going to call it on the rendering thread, which will have our whole compute list process, and then we have our callback. Is call on what are we doing here? Call it on the rendering thread, which is a new callable. Callable from. Might be able to get this into a actual method here. Yeah. Thread, and in this we're going to have we get all of that in place. Just be able to be callable from, right? Yeah. So we're going to do a so that should be what we need to get that. So we're going to say forget data async. Okay, so now we're going to need to get our should actually have this. Compute shaders. There we go. C# code. We've got our rendering device. We've got our code. Let's make sure we get our collision shader. For now, we're going to have nothing. Does nothing. We're not adding any buffers. Buffer get data. That is for the buffer. Is this actually functioning? Okay, for the buffer, we're saying this is the buffer that data is going into. Okay, so we need to create our buffer. IDs. Okay. Okay, we're going to create one buffer here. We'll just use our types buffer. So then during compute collisions, what we're going to do, we need to set up all the pipelines and whatnot. And again, folks, this is a big part of a lot of coding is finding references. And getting everything kind of lined up to use. Pipelines, where is it? Buffer pipeline uniform set. Okay, so we're going to have a compute pipeline, which we're going to make, which is another RID. If we're going to end up freeing that every time. this working, we are going to create our compute pipeline using our shader. So that's up here. That is from collision shader. So now we have that in existence. So we make a new compute list. This emits a so we have bind it to the pipeline. We have dispatch it and then end it. Pipeline. One. And compute list end. All right, so we look back over here, compute list end, rendering device submit. So then we're going to say buffer get data async. With our buffer and our callback. Looks like we might need Callable. This. We're going to say invoke physics done. Okay, a lot just happened. Let's see what broke. Mit's world steps done. Isn't getting anything. Ah. Then in our base world state. Yes, okay. Hello again, Molly. Okay. Okay, compute collisions is definitely getting called, but our other callback isn't. Oh, here we go. Okay, let's run it on the Godot side and verify what's happening. There might be a missing bit here. Oh yeah, there's a lot of missing stuff. Ah, okay. If not, Molly has joined me again and is making biscuits. Okay, we're gonna build that, make sure it's working. Okay, we're gonna go over here, clear that out, run it. Okay, back over to the C# side. To here. All right, we might not be able to get that breakpoint. So let's on physics done. Yep. Oh, wait. No. Okay. Let's look at our implementation here. We've created a storage buffer. Not looking at the uniforms just yet. Okay, we do need to create our uniform set. We need to get the buffer in there. And uniforms are another... Yeah. The uniform set, is something that needs to be released when we're done. Hey, Captain. Yeah, a while ago we were doing collision detection via shader, and we're actually looped back around to that. So we're getting there. Typing around cat right now. So first we're going to do a new uniform. Say it's a storage buffer. Let's copy you over and already uniform this. And then we're going to get add ID our buffer, which is our underscore type buffer, and then our uniform set. Then we need to put that uniform in here, bind uniform set. After the pipeline. Run it over here, verify if it explodes. Still not functional, but we can see if there is more going on over here. Set's not used by the shader, which means we need to get that into our GLSL. Is going to not a structure. Just a types. Buffer is meant to be currently a byte array. Can I even use byte in there? We're about to find out. The real question is, since we're messing with the all right, 6 unexpected identifier. All right, let's. We're simplifying. Oops. Bytes. Then in the shader, okay. Storage buffer binding must create. Okay. We didn't have a buffer. Okay. Well, we're not getting any errors there, so that's a start. Compute collision on compute done. Loading screen isn't showing up correctly. Base player state is having trouble finding it. Okay, let's just try to manually fix that. Services, state, player, that. There we go. Hey, I mean, it's further along. It's further along. This exists. Yeah, I mean, there's a lot in the shader like languages that show that it's very much focused still on essentially variables and similar in structures that are oriented towards graphics processing, and you can easily work around that. It's just, you know, it wants them in those nice little 16-byte packages. So everything's going to generally orient towards those kind of larger size chunks, most likely. Oh. Then what are we missing? Yep. '86 on as an exit tree. The uniform set. So by the time we get here, that uniform set is invalidated. Can I not keep it? Do I have to make it new each time? also be. Well, that's interesting. Or not. Come on now. Okay, it is firing it once. So we are getting that far. But we're just never getting to here. We know as far as Godot is concerned, one of those things doesn't output correctly. Shader is null. Okay, so it's that it doesn't compile, and that will ripple through everything else. Yup. I discovered recently when I was reviewing this to start down this road again that there are like particular compiler tags and whatnot that you want to use in C# to tell it, no, I really mean it. It needs to be in this order. here we go. Okay. Not be used. Maybe an instance name is needed. Yep. When I did this the first time around, Captain, the one of the problems that we had was that I had put in the struct, because of the padding and because I didn't have that compiler directive, my calculation of the padding was off, and I needed to like slide one variable down one line, like swap it with the line below to make it work right. Probably just misreading how they set that up. So I don't have the variable name there. One of the games I periodically play on this, if you recall, or if you haven't seen it, Captain, is the observation duty games, and I refer to those as auto gaslighting games, where you convince yourself, like you are actively convincing yourself that you didn't see what you saw, or that you saw what you didn't see, and coding can fall into that territory. We still have invalid RID free in that. And we are going to look in our shader collision. And we want to hook into our callback. Our callback isn't happening, otherwise we would move at least once. Placing it, and it is in our shader collision manager on 189 and 187. The uniform set and the pipeline are already dead by exit tree. Okay. We are going to move that down to here. And we're going to move this down here. So we create the uniform set in this, and then in our callback, we will clear it. Well, we cleared that error. That's good. But we're still not getting our compute done. Again, this could be a problem with how we are actually running the shader. But we are performing data, we're running into it. Okay, I mean, it should be doing a thing. Making the rendering device, we are setting it up, it is actually compiling it. We don't have anything, the input bytes are empty, so we don't really care there. Saying that binding 0 is our uniform. Bind pipeline, bind uniform, bind do the list dispatch, do a compute list end. When I initially was learning to code, there was a period where they required everybody to use Sun Microsystems terminals, and via command line and similar text editors do all of the code and build there. Like everything had to be written there for that whole part of it. Eventually, you know, they let us use things like IDEs and whatnot, but there was a period where it was, no, everything has to be at command line because suffer. We submit it, and then we say get the data from it asynchronously. Now, it could be that our callback just isn't doing its thing. Calling it on the rendering thread. using a callable. We know that this, in our code, this part is happening. And we know we're getting to this. Okay. Wondering how long it's going to take before I manage to blue screen the system again. Last time I was messing around with this, I feel like I must have like gotten something unpleasant running on the graphics card, but it didn't like end. Because some short period after the stream, it took the PC down. During device vsync frame queue size. In the C# code that I was looking at. Rendering device, staging buffer. Okay. Because we're not getting any errors in here. And it's shut down, so... Okay, then let's do this differently. Start step, surfaces, step, resolve. Equals. friend had to work with. They lived in Austria, and their programming classes involved. Yeah, I had some circumstances where they were demanding that everybody take and do some work in COBOL and like raw SQL because they had a major corporate funder for the department, and those were the tools that corporation used. So it was sort of like a intern pipeline for them. Okay, and then be submit and then sync. If computing. Oh. Okay. It's running. So we are submitting. It is coming back around. I don't know if we're going to be able to do that in game start step. We may want to put it somewhere else. I can do things like I can put a little bit of delta spin on it and say, if it hasn't been at least like this long, don't let it go through. Okay, so when we run it, when we submit it, when we set it up for dispatch here, we've got these three little bits. Which is currently 20,000. So we are going to do no, that's not quite right here. This way. By 100, 10 and 10. And then inside of the shader code, you. We'll solve this later. Oh yeah, there's nothing wrong with learning SQL. That's still handy. Here we need to get the data buffer back. Copy. In theory, okay, we'll just do this brute force here. Okay, this will be just gonna call on compute done with buffer data. Buffer get data. Do data offset where we're putting it and its length. Yep. This types. Okay, it's running. I like some different music now and again. But as far as pretty much all the streams right now, it is very nice to have calm music. Doesn't have to be, you know, like classical or anything in particular, but this very nice calm music. And I do like strings and piano, though. All right, now let's do... This is... And then we need to go in here and in our collision manager. Ho! All right, we're definitely overtaxing the system. I mean, that is too many to operate with for any individual batch that way. Second here. Let's look that up real quick. Okay. this. Score types. Again. Or 256 per work group. So Z can go as high as 64. How would we break that up cleanly? Because what we have is we have a yeah. So what I'm looking at is saying that except for itself, we are going to be comparing each entity to every other entity. Then we're going to take that information and we're going to store it off. There's extra song and dance that's going in there, but so for every entity, we're going to say, okay, which one is the initial one we're dealing with? And then which ones do I look at? If I break that up, yeah, okay. So it's something like 1024 is the most you can get in work groups in Godot. Math. Okay. So if we were to do something like 4 and 4 and 64. That'll give us 1024, and then we can divide each of those up into its own little segments of determining all of the things. So it should be like x times y plus z for which one you're sitting at. Okay. Hey, Roman. Hello, Sky. Hello. If index is less than this. Take that out of that for loop. Life is what it is, Roman. I appreciate that you wanted to swing by and watch, though. Okay, it is running. Doesn't seem... math's not mathing there. Because I'm getting duplicate numbers. That's right. No. Yes. Right? Oh... All right, Captain. Thanks for swinging through. So what we're trying to do right now is get a compute shader going on. It's for any one dimension. Yeah, okay. I see. So we can go even further with that 1024. No, that's not right. I'm just trying to suss out how to do it precisely here, Roman. Oh, there's a problem with the shader, so that's not going to help. Way back. Okay. 11 and 13. Temp high p uint. Okay, well, a uint is fine. Expected if semicolon. Verify if we get any errors on the Godot side. No debugger errors. Go over to the C# side. Go over to shader here. But what we're working on is we're getting our collision shader up and running now. We spent kind of the first portion of the stream getting our... We spent the first portion getting the sequence of the game updated to be cleaner. So now the core game loop is just these messages. And then there is another entity, our base world state, that gets one of those messages, as well as messages from the physics portion, and does its loop in a vacuum otherwise. So aside from knowing that is the game paused and has physics completed, it will just do its messages. And then the physics portion is kind of codependent with this one, is whenever the world state is done, it updates itself, and then the world state has to wait for physics to update itself. Doesn't... Verify that I'm remembering that portion correctly. X into Y into Z. What kind of physics? So at the moment, it's just going to be pure... Well, okay. It's complicated. Every object has a series of kind of little micro modules for behavior. So if something were to be knocked back by a impact, that's part of a exchange of those behaviors. We're working on the logic that says these two things bumped into each other at the moment. We are redoing that logic. Yeah, so part of it is that level of complexity, like allowing for it. So I think the game still runs right now, so yeah. So, like, how those mice are moving is their behavior. They have locked on to, most of them locked onto that one and are slowly kind of like seeking it. But now that there are other targets, some of the mice lock onto the other targets. But I can change the behavior of the mice dramatically. In this case, there'll just be a lot more of them. But they're still trying to do the same thing, is they're picking a target and they're trying to track that target, but with a limited turn radius. And I can add other little bits to them, like now they're going to move with a sine wave motion to them. We'll start again and we'll do that so you can see it better. So this is composite behavior. Is first they go in and they say, okay, where is my target? Try to move at my target, rotating as necessary. But then a second bit of movement says, well, I get half of our movement, and what I'm going to do is have us move left, right like a metronome. So the two movement types are combined. Feels like this is right. So I'm doing 10 of these. So this is 0 to 10. And each one of those does 0 to 10 of this. And then each one of those, for each one of those, we do 64 of these. So it should always be x times y plus z to get us where are we in this list. And if our index is within range, we set the data values. But it's looking like it's coming out skewed. So we're getting these fixed values here. And we're getting a lot of repeats. I guess that kind of makes sense. Maybe I'm... It seems like it'll be right, but... Same problem. There have been a couple of games that will do the sequential behaviors. As far as games in general, as far as that sort of modular behavior, the one that we're really basing this off of is called Noita, Noita. We used to play a lot of that, where your weaponry is kind of a sequential 10 pieces instruction or X parts instruction set. So, fire this, and then this, and then this in sequence. But you could also add modifiers and conditionals in there that could result in wild changes of behavior. We're kind of taking that concept and instead of having a sequence of projectiles in order, it is a single projectile with its sequence of instructions on how to behave. Should be plus. Okay. Yeah, our math is wrong here. Okay, so every y is a 64 that it's incrementing on. So this is additive. Every y that we go up is another 64. Increment that we're dealing with. And that's up to 4 of them. So then that would be 256. This shouldn't be as hard of a math as I'm making it. I get the impression that this is copying back wrong. Bytes into Data bytes into types, the length of the data. Well, for one, I'm trying to make sure that I'm calculating this correctly. And that's that I have what amounts to a nested for loop. You know, for x equals 0 to 3. So x will iterate 4 times. And within x, y will iterate 4 times. And within y, z will iterate 4 times. 64 times. So what I want is to translate that into a single index. Yeah, like the final number that should be like which one we're on. So if I were to be incrementing a number in those loops, kind of like this is for x is, you know, if I were to add them together, or if I was to add 1 to a number in the middle of this, what would that number be at each value of x, y, and z? And this should be stupid simple. Four and four. But that's not right. No. We're also not looking at data. I could have been correct. Okay, breaks down after that point. It's fine. It's fine. Yes. Types. Should get out to 1024. Yep, 1023. Okay, excellent. Okay. I'm getting there. We're getting there. Okay, so that gives us a segment that we're dealing with. Then each of those segments will have a multiplier associated with it. This is unneeded. Well, this is extraneous work, but we're going to do it. Exactly there, Roman. Exactly. I need to round up. Numerator plus divisor over divisor. Sometimes dumb solutions don't have to be dumb. You basically just boil the solution down to its absolute basics. With that, you can either discover a new path or you figure out the solution you might not have thought about. Yep. It's this whole process that I've been working on has been a great deal of iteration. I is equal to 0. I is less than plus. Okay, so now we're padding them out and saying each of these is a segment. Now I can do that with these. But I would need to pre-calculate what the segment size is going to be. Which I can absolutely do. Let's just do that. Let's just do that. One of them is going to be 20. Okay, so instead of determining segment size here, we are going to get our local x. local invocation index. Okay, we run it over here. 13. .x. This, and then types. There we go. Iterating over all of them. There is wasted processing at the end. Oh, I'm sorry. We just did... So we have an internal work group of size 20 here. So this code will be run 20 times per thread, essentially. There are about 1,024 threads being set up for this. We're saying this is the index for it. So you handle this particular spot. So then what we're going to do is... So we're going to start after our self, because we don't collide with our self, and we're going to run all the way down. So this code is brute force collision. We're going to take every object and say, actually, no, we're going to start with all of them. We're just going to skip ourselves. So for uint I is equal to 0, I is less than data size I plus plus. We will be going through and we're going to take every other element and compare them. Now I can save some time by saying that it starts at index +1 and run that way. And then we can just say, well, uint I is equal to index +1. Just verifying that this is how it works. Into our, nope, not in the data, that's in bytes. Yeah, that's wrong. Determine the index, which is the actual one being checked. And each one being checked... Oh. I mean... Oh, it should be kind of reversing it. Doesn't seem right. Okay, so we go in and we're saying, okay, this is the size of the whole data collection. So we have to operate within that. So we get our index and we're saying that index and we're saying it equals I. Get our index, and then we're just going to say the data size. Go again. Okay. So now we'll actually do the iteration. So that it does the work, or does some of the work. Let's see if I is equal to 0. That, and then for each one of these, that is Molly. She, of all of them, if she got at the keyboard, she would probably damage it. Primarily because in dry air, she just electrocutes all hardware she touches. Very zappy cat. that's not correct. That, save that, go over here, compile, run it in Godot. Check for errors, no errors apparent. Go back over here. Run it again. This. Types. That's can't really be correct. Oh, no, it can. Because from then on, we're just feeding that buffer back around. But no. Can't be max float. These numbers don't make sense. I have a playlist from Epidemic Sound of just various things. I won't be able to catch the one that was just playing. Actually, that one, it was Gravity and Growth. By Eneide. But everything from some Bach to arbitrary other stuff. An Epidemic Sound? I think it is. Isn't it? Yeah. If you look at the bottom, well, on YouTube, in the descriptions of my stream videos, at the bottom of it, there's a link to the playlist that I use. That number doesn't make sense for what we're doing. Shader compiles correctly. And in our shader, what we're doing is we're saying, okay, this is 20,000 long. We get our index, which we know lines up to the numbers. So if index is less than data size. All right, this will be our last little attempt here. There we go. There we go. Nice. Okay, still within reason as far as collision detection. Now what we need to do, the next thing we'll be doing is setting it up so it actually has the data and that it then generates the collisions. There's plenty that we'll be able to do to further tune it. But the first thing will be getting our data set updated such that our buffer will always have new information. Because right now we just create the buffer from it. I don't know if this is everything we'll need, but we'll go from there. We'll go from there. Ew, buttons. All right, though, folks. Thanks for joining us today. Is the code available to look through on GitHub? No. Well, it's on GitHub, but it's all private repositories and whatnot. This is, my personal project. Once I'm done with it, all of the data files will be available, and quite frankly, it'll be C# code, so even obfuscated, you'll be able to peruse it. Let's be realistic. But yeah. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All of those buttons are generally good, so I'd appreciate it if you press them. If you'd like to help financially support the channel, you can do so through platform-specific means, as well as other options that can be found in the link tree in my video descriptions and in my bio. But with all that said, folks, I hope the rest of your day is good, and I will see you next time.